hopefully you will recognise discriminant. Discriminant is given by this b squared minus 4ac. I've given you a clue. I just told you. The discriminant is in the quadratic formula, yes? Okay. And if we just focus on the discriminant part of the quadratic expression or equation, it tells us a lot about that graph. Okay. So, what is special about the discriminant when we are putting it into the quadratic formula?
It involves all the values for A, B, and C.
Yes, but if we were to chuck it in the calculator,
Does have to be done here.
well, yeah, I'm not really asking, I'm giving it away. What's this sign here?
Is it square?
And so what's going to happen if this value here is negative?
Oh, you can't do this.
You won't be able to do it, okay? And that will come into play a little bit in a second. Okay, so we know that if this value here of this expression is negative, it means that there's an issue, okay? And we, up until this point, we haven't been able to say anything about any roots. So, b squared minus 4ac is called the discriminant, and it can be used to determine the nature of the roots. So in other words, the roots are where the graph touches the x-axis, okay? So, if this discriminant is, what does this mean? Greater than 0. Okay, so if the discriminant value is greater than 0, it means that there are two distinct real solutions. What does distinct mean? They're essentially different. Okay, so there are two distinct real solutions. In other words, your graph, your quadratic graph, is going to cross your x-axis in two different places. Okay, whether the value of a is positive or negative, you're going to have a positively happy or negatively sad graph. It doesn't matter. Your graph will cross that x-axis in two different places. Okay, so some questions will say, here's your equation. How many times does it cross the x-axis, or how many roots, or how many solutions are there? So you look at the discriminant only and know that it has to be greater than 0. Okay? If the discriminant is equal to 0, it means that there's two equal repeated solutions. Okay, so two equal. In other words, just one value. That kind of situation is like, for example, when we would have that. We know that it only crosses at 2, therefore there's just one solution. Yes? Again, doesn't matter if it's positively happy or negatively sad. So if it's equal to 0, there's only going to be one answer. Now, this is a situation where we were saying what happens when it's negative. So our calculator tells us that that quadratic equation is an error, and that's because our graph does not touch the x-axis. Okay, so it means that it's going to be up here or down here, but won't actually touch it. Okay, should be ants. So, easy one. Find the discriminant and hence say the nature of the roots for each of the following equations. I do get confused. Have we talked about the word hence before? In maths? Not really. So if it says hence, it means that you must use the information you've just worked out. So it says find a discriminant. So the fact that you use the word hence tells us that we have to use this information in order to answer our question. In some cases, your question might say hence or otherwise, in which case they don't care which method you use. Doing what they've asked you to do should help you, but you can use an alternate method. But if it says hence, it means you must use that information. Okay? So there's some terminology for you. And it's important because some people just ignore it and they just go off on their own tour. But you must, as I say, if it says hence, it means you've got to use what they've just asked you to find. So, discriminant, so we're identifying A, B, oh, that's close. B, and C. What's A for this bad boy? B is, and C is, so B squared minus 4AC is negative 5 squared. Subtract 4 lots of 3, lots of 2. Negative 5 squared is 4 multiplied by 3 multiplied by 2. So that's 1. So B squared minus 4AC is 1. Is that greater than 0, equal to 0, or less than 0?
Greater than 0.
So therefore, two what are the distinct groups? Easy, easy, lemon, squeezy. Oh, next one. Oh, this would be on the paper, the calc paper, hopefully. Okay, A, B, C. So A is, B is, C is. So B squared minus 4AC is negative 28 squared. Subtract 4 lots of 49. Oh, shush now. Definitely count there. Alright, so we've got 0. What does that tell us?
There is two
Yes, two repeated, yeah. Therefore, two repeated real roots. Two repeated? Would you say two repeated or one repeated?
This is one repeated.
Yeah.
There's two values. They're just repeated.
Yeah. I know.
You have four.
But it's like,
That's like a repeated real group.
I just have to put one just put repeated real root.
Yeah.
I just looked at that and thought, actually, I'm not quite sure what we but you know what the deal is.
Yeah.
Just one option. Okay, what are we going to do this bad boy first?
Make real.
Nice. Nice. So 5x squared, 3.7x plus 5. Of it?
Did you actually speak Dutch?
Pretty well.
I'm a gibberish.
That means a little bit.
Okay. I'm tempted.
Alright, so we've got 5, negative 7, and 5 with. So b squared minus 4ac is equal to. Negative 7 squared is 49. 5 plus 5 is 5 times 4 is
100.
what's 49 subtract 100?
That is 51. Negative 1.
Negative. Okay, so it's negative 51. What's that tell us?
That is no real, yeah.
No real roots. Solutions. So, unfortunately, you're unlikely to get those math questions. Just there for you. You might know.
Well,
You're more likely to get these kinds of issues. So it says solve. So the fact that it says solve means that we're going to be finding the value of something, yes? We know it's got two real distinct roots. Okay, so there's two different roots. So therefore, what do we know about this expression?
it's greater than 0.
It's what it.
It's the discriminant.
The discriminant. Okay, so first things first, we need to find an expression for the discriminant, yes? So, find discriminant. So, b squared minus 4ac. So, in our case, what would that be?
Negative 2. Why not?
Because it's positive.
B squared.
So it's just b squared. Huh? B is just B here. Remember, it's not the minus B plus or minus the square root of. It's just B squared. Subtract.
Minus 4 times 9 times 4.
And that discriminant we know has to be, you told me, greater than 0. So therefore B squared subtract, yeah?
36 times 4 somebody? 36 times 4 is 144.
So what do we do now? Solve.
Add the 144. Yeah.
Yeah, you can say that B squared is greater than 144.
1 squared of that.
Now, yes, be careful here though. So we've got a square value is greater than 144. So remember, you can't just say B is greater than plus or minus 12. Okay, do you remember that?
It has to be 1.
Because remember, you've got square roots of things. So this is where you want to consider what would this graph look like? The B squared, which is the best one? B squared, okay? If it's looking like that, yes? It's got to be greater than 144. So here's our line, the 144. Yeah, you happy? It's got to be greater than that. So we're talking about these values, these values and these values. We know that this particular value is what? Careful. And this one is. So if we talk about these values and these values, it means that B has to be what? 13.
Greater than.
Careful.
Oh, yes, sorry, that's my
Greater
than.
less than. And greater than.
Nice. You all happy with that?
Yes.
Yes, totally will. Right, so we are picturing our B squared, so obviously x squared makes no difference. Consider it's 144, obviously nothing is drawn to scale, we're just having it as a visual. We know that these two values would be negative 12 and 12.
Yeah.
You're happy with that?
Yeah.
So if we're talking about that our graph has to be greater than, it means that we're talking about these bits on the top. To get a value up here, we have to talk about B values this way,
Yeah.
or B values that way. Yes? So then we've got two separate values here. Yes? Okay, solve for all real roots. Okay, so we're just talking about real roots. So remember there was a situation there where there was no real roots, so we are going to say that there are real roots. Whenever you see this kind of word or it talks about the nature of values, you're always going to be finding an expression for the discriminant first. So let's establish our A, B, and our C. So what's our A? Okay. B, 4. C, 3. Okay. I think it has to be 3 plus K. It is 3 plus K, yeah. Now it might be written in your question like that, it might be, but it might not. So I just want you to accept that the nature of quadratics is that you'll have a value of x squared, a value of x, and then anything else is going to be your value of c. Okay, so that's why I didn't put it in brackets, so you can see that sometimes you might have to recognise that. So we're finding about an expression for our discriminant. So we've got 4 squared minus 4 plus k plus 3 plus k. And what do we know about our discriminant if it's all real roots? So it could be a repeated one or it could be 2 different ones. So if it was a repeated root, what would we say? But what do we know about the value of the discriminant if it was a repeated one? It equals 0. What do we know if it was 2 different real roots? So we need to have both of those situations. So what symbol would we write here? Greater than or equal to. You're happy with that?
Yeah.
So now we have to expand and simplify this bad boy. So we've got 16. Subtract I'm going to do it in 2 steps, 4k and 3 plus k. And then 16 subtract, and we've got 12k, and then subtract 4k squared. So you're good at that, make sure you're comfortable with that. Alright, so we now need to find our 2 values. I can see that I've got a common value here. What have I got? 4. I would actually probably even take out the negative 4. So that would give me negative 4 plus 3k plus k squared. Alright, so you've got k squared plus 3k minus 4. Maybe we need to write it that way. So, find our 2 solutions. So we need to find 2 numbers that multiply to negative 4 and to give 3. Minus 1, minus. I did, but minus 1 and 3 doesn't multiply to negative 4. Minus 1 and 4. That's it. So we've got. Oh, I didn't really leave enough space this time. Sorry about that. Alright, so again, we need to consider our graph. What does this look like? So what are our 2 intersecting points? We've got 1 and negative 4. Yes, remember that? Great. This negative 4 in the front though, what does that mean it looks like? Positively happy or negatively sad?
Negatively sad.
So it looks like that.
Yeah.
Again, scale is nothing going on here. Like that really is not what it looks like. We're trying to find out when that graph is greater than or equal to 0. So it's greater than or equal to 0 when it's here. Yes?
Yeah.
So how would I describe that? Those values.
About the actual
When we're talking about these values. So this would be a range.
Greater than minus 4, less than.
Yeah, so you would start with negative 4 is less than, let's just say k, which is less than 1, yes?
Yeah.
But recognise that it's the or equal to, so we need that background as well. So, don't forget, so when it's, for this one here, you can see it was 2 separate parts of the graph. So that's why we had 2 separate statements, inequality statements. For this one here, it was all the bits in the middle, so you could write it as a range like this. Okay? Alright, so for what value of a does ax squared minus ax plus 2 have a repeated root? So, we find our discriminant. So, a is a, b is negative 8, c is 2. So our discriminant is negative 8 squared subtract 4 lots of a 2. And for a repeated root, what do we know that it is equal to 0? So 64 subtract 8a equals 0. 64 equals 8a. 64 over 8 equals a. So a is 8. Done.